Good morning. Good morning. We have Liam and Grace and Jessica and Hesong, Will, Peter, Emma. Okay, let's start. Emma, can you give us update where you guys are?
Yeah, I don't have a lot of updates. So for Eugene's paper, I reached out to him and he told me that he has submitted to 3 journals so far. They were Cancer Treatment and Research Communications,
Hmm,
Molecular Cancer Therapeutics, and Clinical Lung Cancer. I think I
mhm.
rejected by all 3. So on Wednesday, I submitted his paper to Helion
Mhm.
and there hasn't been an update since then. I think they haven't like assigned it to a reviewer yet or anything. And then for the variant classification project, we're still waiting to hear back from Dr. Easer. I just did a follow-up text. So we're
Mm,
hoping to with her first before we get started.
mm,
And we'll probably do that this week.
yeah, so go on to the journal uh website, almost like weekly basis, make sure they didn't return. Because I'm corresponding author, they send email to me mainly.
Yeah.
A lot of times it goes to junk mail, and yeah, so you need to check yourself. Okay. Any technical questions on the other project?
No, not this week.
Okay, very good.
So,
Peggy, can you give us update?
Yes, actually, I'll have a presentation about the subject I have been investigating on about the chip. So I have a presentation,
Well,
and
before we get there, let's do it at the end.
okay, I see. And before, okay, beside that, I have completed the result part of the paper that I have been working on about the mixed response of the cohorts from radiomics data. So I'll show you the result part right now. Wait a second, please. Here you are. So I have a question about like how to name this cohort. Like I just arbitrarily like named this A mix yes and no. So are there any better names that you suggest for the name of the
So can
cohort?
you tell all the lab members what is the title of this study and why you're doing it, just so that we can learn from this?
Oh, okay. So the basic concept of this study is that
What is the title? Where's the title?
um, I haven't said the title yet, sorry. So I just written the result part of the study, and
Can you tell me
yes.
what the title is then?
Mm, so should I like make a title right now, like
Yeah, yeah, yeah.
from this result? Okay, the title would be mm, the survey the can you please help me set this title? Like I will like make a draft about like this. The survival outcome. What can I say?
So I say, so the clinical implication of mixed response in patients with non-small cell lung cancer treated with immunotherapy.
Hmm. Okay, so thank you for your help. Like the title would be the clinical implication of mixed response in patients with non-small cell lung cancer treated with immunotherapy. So there's a concept called mixed response. So yeah, normally we subcategorize the progression of cancer into like SDs and PR and PD and CRs. So there are like 4 criteria in 4 subgroups in RECIST criteria, and they all can show mixed response. And mixed response means when a cancer, when there's multiple lesions, and some lesion can grow and some lesion can regress. And if there's both regression and progression in a single person, we call it mixed response. And we made our own criteria to evaluate the mixed response, and which is definition A and definition B.
Can you show us the figure that Dr. Jian made?
Okay.
They can understand.
Okay, I'm sorry, I have to find this. Wait a second, please. From the messenger. Okay.
So for those of you, when cancer respond to a certain drug, each lesion, whether they're all in lungs or liver, different organs, they respond a little bit different. But sometimes one lesion would shrink, one lesion would still grow. So if that happens in the same person, then we call it mixed response. Some people call it dissociative response.
So basically, yeah, so we made we made 2 definitions for mixed response, and the definition A means when one lesion like grew over 5 millimeters and the other lesion regressed more than 5 millimeters. We called it definition A for mixed response. And for B, if a lesion increased in any size, like it can be 1 or 2 millimeters or 5 or 10 in any size, and the other lesion regress in any size, we call it definition B. And we analyzed both A and B in our cohort to see whether there's a mixed response. So yeah, here it is. So according to our analysis, like definition B was a little less significant than definition A. So we worked on definition A for the analysis. And here are the results. Yes, so we both analyzed according to RECIST and IRECIST criteria. And here are the numbers of the patients who showed mixed response according to definition A. So there's definition A mixed yes and A mixed no. So if if a person met the definition A criteria for mixed response, we call it A mixed yes, or if didn't, we call it A mixed no. So here is the table for the demographics.
You can't
Oh.
see the table.
Oh, sorry. Okay. Okay. Once again, this is the table for the demographics. And yes, so yeah, A mixed yes stands for the people who met the A mixed criteria, and A mixed no stands for people who didn't met A mixed criteria. So this is the demographics table. And interestingly, among patients with SD, so this red plot stands for A mixed yes, and blue plot stands for A mixed no. And the left one is PFS and the right one is OS. There's no significant difference between of a PFS among mixed people with mixed response in SD, but there's a significant difference in OS among SD patients. And this is according to RECIST criteria, and the same goes for IR RECIST criteria. So if you
The direction is really important. If you have mixed SD, look at the overall survival is really poor. That's because some of the lesion grew. And the fact that some grew is a negative indicator. Now, I mean, it's no brainer. But I mean, to see that it has such a big difference in overall survival, it's eye-opening. Now, this is definition A. Do you have definition B graph?
I was planning to put that in supplementary table, but I haven't, but I can show you the analysis the graph I made.
Yeah, so was the definition B.
Wait a second, please. Okay, I found it.
Okay. So where is the
Oh, actually, I cleaned the data after I made its graph, so that this looks significant. But like, if I didn't run the analysis after I cleaned the data, so it might be quite different if I do that. So this is not accurate. Sorry.
so there's where's the OS?
Okay. Yeah. OS is the same, so I'll show you. So for RR resist, there's another one. Should I share with you?
Yeah. So next time, show me all the raw data so we can pick.
Okay.
I don't see any screen shared.
Oh, sorry. It's, this is OS for resist criteria with mix B,
Mhm.
and this is IR resist with OS.
Okay, so very similar trend, but yeah. Okay,
Okay, so back to the paper. So the p value was much more significant for mixed A group, but I will put the mixed B graph and the data in supplementary table, so that to make sure. And
you know, I think mixed resist OS and PFS. Show me the PFS.
oh, I just told you that the graph is wrong because I cleaned some of the data from PFS data, so the graph is wrong.
Mm.
So this won't be meaningful. Like for like PFS, there was some blank in the Excel sheet, so I filled it out. And after I filled out the blank, the PFS turned out to be not meaningful, not statistically important. So if I run the PFS with mixed B once again, there will be an accurate data, but I didn't. Sorry.
That's okay. So I resist will be supplemental. Resist mixed type A or B. Let's make that all in a regular table. Because they're the same.
Okay, so put IR resist to supplementary and mix A and B to the regular paper. Okay.
Yeah. Okay, go back to your presentation.
I see. So the trend. So the interesting thing here was that, as opposed to SD, among those who showed PD, there was a reverse trend that
So
mixed
I'm still seeing the same graph.
I'm sorry. Okay.
So what you can do is you can share your whole screen. That way you don't have to go back and forth.
Oh. Sure.
But you have to
Okay.
you
Oh, I see.
have
So
to put in your personal stuff. Otherwise, we can see all of your.
okay. Sorry. And yeah, as I told you, there was a reverse trend for people who showed PD, and those who showed mixed response had favorable overall survival. And it was, although it was not that statistically meaningful, there was a definite trend that people with mixed response had better survival than those who had no mixed
Can you
response.
make that bigger? I'm seeing 2 page. Can you just show me 1 page?
Okay.
Can you make the full screen? Okay. So p-value was significant. Not significant. Okay.
Yes, I mean though it was like 0.08. So
This is definition A. How did
yes.
definition B look like?
Okay, I'll show you. Uh, oh, so for definition B, it was like totally not meaningful. Like for A, it showed 0.082, but it was like 0.9 for definition B here. S- So it
Where-
was not meaningful at all.
But do you have the graph?
Um, I'm afraid I don't have one. Like
Okay,
after I should. Mhm.
that's okay. Yeah, you can proceed with your presentation.
Okay, thank you. Mm, So should I have to put definition B for PDs? Like for SD, you told me to put both big A and B, but like there's no significant like.
It's okay. You can still put it.
Okay, I see. So yeah, I will put R resist in supplementary table. So for PR, they were all not significant. So yeah, you wanted me to put the table, the graph in supplementary table, and I just wrote the description for PR about how how it came out to be. And the graph here is like, this is graph for PR patients, and which showed no significance. And
Maybe probably because of sample size.
yeah. Mhm.
Yeah, okay.
So next time, yeah, I'll bring mix A and B together. Uh,
Mm-hmm.
and this is pretty much it for this project, and I'll work on. Do you want me to write an abstract first and like write the manuscript later, or do you want me to make a manuscript and then write an abstract?
So you always write abstract first.
Okay.
So for all of you who are doing a certain project, my recommendation is always write the title first. If you don't have title, you don't know what you're writing. And you might be
Oh.
writing something that's not related to the title. So
Mhm.
always, if you're not sure, go back to the title and then write abstract first. You have your results from your analysis, from your statistical analysis, everything. So write your abstract first. Then you can write results. Then you can write introduction. You can do that simultaneously. And then after discussion during our lab meeting, I will tell you the points. What are the discussion points? What are the reference articles you should cite? And why are we writing this? Why are we doing this project? How are patients going to get help from these projects? We're not writing project because, oh, it's going to, be good for my CV. It's going to be something writable. I finally have something I can write. No, it's not about you. So every project that you do, you have to think, how is this going to make difference, change practice, help patient? If you're not convinced, that what you're doing, I'm uploading CD-ROM. Like, how is this going to help patients? You have to be convinced. If you don't know, ask your manager, your mentor, people around you, why am I doing this? Like, you should not do any simple labor without knowing what implications it will have. So always ask, don't just do things that you're told to do. Same thing, I say mixed response is important. Like, why is it really important? Is it really important? And why are we doing this study? Like, I think, and then if someone did similar study as this one, keep reading. Like, what are the other papers? What did they talk about? What things did not talk about is more important once you understand what they talked about. So that's called niche. There were similar papers, but they never discussed this. So I'm the first one in the whole world discussing this. So I don't want this paper to be me too paper, right? I don't think any paper looked at it with definition A and B. So this would be the first paper in the whole world using different criteria to define mixed response. Number two, any paper looked at PR, SD, and PD at the same time? I don't think so. Maybe they did, I don't know. Taegu, it's your job to find out what other people have done. It's always, doing, you cannot write your paper unless you get into a position, we call it shoulder of giants, shoulders of giants. That's how you get the view. If you kind of just read represent only a few papers, you'll never get there. So you have to read all relevant papers. That's how you understand where the field is. So mixed responder versus non-mixed responder, is there any genetical difference? I don't know if anyone looked at it. So genetic determinants. Is there a difference in TMB? Is there a difference in specific gene mutation profile? We don't know. Is there a difference in PDL1? We don't know. We have all those information for these patients. And that in itself is more, it's important if you look at it mixed or non-mixed. But again, there's going to be responder and non-responder. So it is very important to look at this in a contextual manner, meaning within the responders, there's mixed or non-responder. Within the non-responders, there's mixed or non-mixed. But you cannot mix it together. Doesn't make any sense clinically. So that's really important. So I think what makes your paper stand out or original is going to be that niche. What kind of niche are you creating? People know that mixed response in responders is bad. Mixed responders in progressor is good. That's no brainer. Everyone knows that 100%. And just showing that in a paper will get you nowhere. So there has to be a breaking point somewhere. Is it genetic determinant? Is it the chemo and the chemo immuno or immuno alone? Is there a difference there? So as you go down into more subgroup analysis, you're gonna run into a sample size problem. But so the next step is work with a DART study, which is 800 patients. And everyone was treated with the same treatment, which is nivo/ipi. So the next job is work with Liam, and Liam will work with Megan to receive all the per lesion data, because that's what we need. So everything you generated from Northwestern lung cancer data, you're gonna work with Liam and Megan to get the per lesion data. It's all in the database. And Liam now has access to that. So get that, learn how to extract that, and do this exact same analysis that you done with definition A and B, utilizing the DART data. Okay, I will send the initial data to the chair, Dr. Kurdrak and Megan, that we will be looking into that. We don't need any proposal. We are the PI. We can do what anything we want. So what Megan is our statistician with DART. What Megan did is she looked at nothing else, just response rate, just the response rate, and the response rate is good enough to predict PFS and OS in a very linear fashion. So there's a cutoff of 20% and 30% for PR and PD, but there's no a curve or anything that justifies the cutoff. It's all linear. So that was oral presentation at last I think ASCO or AACR recently. So it's very, if you think about a statistical exercise standpoint, it's a very simple exercise. Just get the overall response rate and you just show the linear curve. That's it. But no one has ever shown that sort of a relationship before. So that's why it was novel. But so keep thinking about it. And then do all those exploratory analysis on and give me update real time. Don't wait for Tuesday. And go from there. And so the goal is, if any one of these people, let's say mixed responder versus non-responder, have any other traits, like we have genomic determinants, but can we use radiomics? So within can you use radiomics to determine who's going to be mixed responder and who's not going to be responder? Can you do that with radiomic features? So work with Dr. Yuri to find that out. Okay. Can you use H&E slide? And in the H&E slide, can you come up with a heterogeneity index? And that's Stas's project. So can you come up with anything that can be associated with what's mixed, what's not, and there are overlapping. There's some of these cohort patients will have H&E slides, so that you can work with Stas or Lunit to come up with heterogeneity index from the H&E slide imaging. So you could really make that kind of association to see, is there anything that relates to, because the hypothesis, any heterogeneity that you see at any molecular or histology level or radiomics level, the heterogeneity will translate into clinical outcome difference. And that would be mixed response versus universal response. So can you find that association? And I haven't seen any clinical or translational paper that show that. So look for any similar papers first. If there isn't one, you're going to be the first one to do that in the whole medical field.
Okay.
So our lab is definitely interested in heterogeneity. How do you define heterogeneity at molecular level, histology level, radiomics level? And how do you use that? How do you turn that into an index, clinically applicable index? And how do you use that to correlate with clinical outcomes such as response rate and the per lesion responses, differential responses, as well as PFS-OS? And eventually, does that correlate with toxicity, if there's any link there? So there are many things you can think about. I'm just giving you ideas so you can develop it yourself. but yeah, and then Dr. Chion will continue to work with you. So yeah, any other updates? Did you look at immuno versus immuno only?
I just analyzed chemo versus non-chemo, and the reason for that is that the cohort and the cohort from radiomics data subdivided patients into chemo versus non-chemo. But I can definitely do another like analysis just because in the non-chemo group, there are patients who receive immunotherapy and targeted therapies. So we can, but there were only 2 targeted therapy patients, so we can exclude them. And the rest was, the rest were immunotherapy patients. So we can delete those 2 patients or not. So
Can you show me who those people are?
okay, wait a second,
What-
please.
What medicine they received? Because it's
Oh yeah,
it's
I can tell that they were lorlatinib and osimertinib.
did they receive immunotherapy?
According to the Excel file, they didn't. But I can recheck that.
Oh, so they did not receive immunotherapy?
They didn't because they only received targeted therapy.
Oh, so you added them into this paper? This project?
Yes, like there were only 2, and we just divided into chemo versus non-chemo, so the 2 were included. So yeah, if you want me to delete those 2 people, I can do that.
Because the title says, if you're not sure, because I don't know if there's any a paper that looked at only immunotherapy receiving patients.
Mm-hmm. Mm.
Do you know? Have you looked at enough papers?
Yeah, I mean, yeah, I did, and as I showed you last time, I will show you the review article for that. I mean, the table for that about the papers that investigated chemo. I mean, the regimens of they received. Here a second, please. And many paper investigated like they subcategorize into like chemo and targeted therapy versus just immunotherapy. Like I'll show you I'm finding this so I asked this to Dr. Jian, and she told me that as long as our data divided the patients into chemo versus non-chemo, let's just include targeted therapy patients. She told me that. So yeah, I was okay. So wait a second, please. Oh, okay. I can share this. Okay. So many papers like divided patients into chemotherapies and targeted therapies versus like just immunotherapy. So
So let's look at it. This is everyone received BRAF, and mixed response was 26%. TTF shorter than homogeneous responders. This was colorectal. Everyone got capecitabine, sorafenib. And they use PET, interestingly. And
Yeah,
then
there were a lot. Sorry to interrupt. Like there were a lot of papers that utilize PET data.
presence of at least one non-responding lesion is associated with poor outcome. And then you have colorectal, KRAS wild type, so you use EGFR inhibitor, 43%. You have non-small cell, everyone got EGFR, 32 mixed response. And no small chemo or EGFR TKI all combined in the 21%. Independent unfavorable prognosis factor for PFS and OS. And breast cancer bone dominant. And then 48%, which is a lot. Time to progression tends to be higher in patients with DR. Of course, and this is all lung cancer getting immunotherapy. So 7.5% better overall survival than true progression. This is, similar to our data.
Yes, it is.
Favorable prognosis compared to homogeneous progression. DR is associated with clinical benefit of immunotherapy. Do you know what that means? So this is probably among progressors, same thing.
Yes. Like I look into this Humbert paper. They were saying the same thing. That these three people were saying the same thing.
So they only did, so it looks like they looked at progression only. They did not do SD.
Exactly.
So looking at it, I think we could focus on SD. I mean, we're gonna talk about PD too, but that's what makes our paper unique. Sample size wise, we're 160. Are we about 160?
Wait a second, please. Sample size was, sorry, 122.
And why is that?
We excluded chemotherapy patients, which approximates to like 80. Yeah, it is 87 to make, because there were a total 209 patients, and 87 were those who received chemotherapy.
So chemo only?
If the patient has received more than one chemotherapy, we categorize into chemo, and the patients who never received chemotherapy, we just made into without chemo.
I don't understand. So first of all, are these patients all first line treated? This is all first therapy response?
No. It's just like all patients with regardless of their treatment line.
So that introduces bias, right? Because some people
yes.
got second line, some people got first line.
Mhm.
It's not fair to compare OS.
Right.
So you need a homogeneous group of patients. So everyone, it's not fair to put lung cancer and head and neck all together. They have different prognosis, right? So you need a homogeneous group.
Yes.
So non-small cell, first line. It does not matter whether they received chemo alone, chemo immuno, or immuno alone, or even targeted therapy. Does not matter. You're just going to do subgroup analysis
Oh,
with, looking at the effect of immunotherapy, monotherapy, chemo-immuno combination compared to other groups, it's okay. So I don't understand where I didn't understand is why you took out people treated with chemotherapy.
because the p-value for those who treated without chemotherapy was so significant, like it was like 0.0002 or something. So we just, Dr. Jian and I just decided to take out those people who received chemotherapy and just analyze 122 patients. And yes, for that.
What p-value are you talking about?
The SD, the among the patients who received without chemotherapy, the analysis of like SD patients, as you see here, like this SD resist mixed A graph, this p-value was so good that we just excluded the patients who received chemotherapy.
So I still don't understand. So p-value is good when you excluded chemotherapy.
Exactly.
So we need to look at all the graphs of all comer and the graph of people who received immunotherapy only, and also of patients who received chemo plus immunotherapy. We need to also see patients who received so targeted therapy is only 2 patients. Yeah, so why don't you put that all in comparison? Because people want to know. So if adding chemo, because no one, so one question is has anyone received chemo alone without never receiving immunotherapy?
Among these 209 cohorts, I didn't check one by one. So there was a column where it shows that the regimen containing chemotherapy. So it was just a column, and like if they according to that column, like if the regimen contained one or more chemotherapy, I just say it yes, it is a patient with that received chemotherapy. So I didn't check one by one for like whether there is a patient who received only chemotherapy. I didn't check that.
So we need to know that.
Okay.
My assumption is our screening criteria of getting all the radiomics patients was that the eligibility criteria was everyone need to be on immunotherapy.
Oh,
Yeah, that's what Dr. Jian told me. That's why I'm so confused right now. It was all frontline. Oh no, it was regardless of.
line, but yeah, it was all IO. I'm not actually looking at the Excel sheet right now, and then I just found one patient who only received docetaxel and ramucirumab, which is a VEGF inhibitor. It's
yeah.
not considered an ICI, so that patient should be excluded.
Yeah, so make sure you know what patient was treated. There has to be a drug name. It shouldn't just say containing regimen. That's so vague. Okay, so you have to know what patient was treated with, and then what line of therapy. So if you wanna analyze first line, do the first line only. PFS and OS. You cannot combine second, third line into one same analysis. That's not doing justice. Okay,
I see.
and then in the first line, most people get chemo immuno. So in chemo immuno, what is the effect of mixed response? In immuno only, what is the, effect? We don't do with chemo or without. We just don't do it. Clinically, what's relevant is most people get immunotherapy. So that's the subgroup analysis, but you can do all comers, including chemo only, including TKI only. That's okay,
Mhm.
because mixed response can happen with any therapy. So you can look at all comers, but then you need to do a subgroup analysis saying immunotherapy only group, and then chemo plus immunotherapy group. Those are subgroup analysis, and showing that in those subgroup, is mixed response, the difference or the clinical implication of mixed response any different by subgroup? So that's the question we are asking, which I don't think other papers have explored. I don't know.
Okay, yes. Okay.
So you cannot just cherry pick the good data and then, you have to show in all of my data set, this is what we see. You can choose to show what's regular figure, what's supplemental figure. But you have to show everything from your data. Okay, you cannot just say, oh, I didn't look at like, chemo group or then the reviewer is gonna say, what did they show, right? So,
Oh, I see.
okay. Anything else?
That's pretty much it for this project. And for the ISD form, for Novocure, I received an email from a statistician, and I
Okay.
sent an email to the statistician to help us figure out the accurate sample size and the power and alpha values for us.
What is the name of the statistician?
I'll check.
Show me the email. And let Haesung know, and Haesung can use that email to, so say, Dr. Che is a cancer center member, faculty, and is writing IIT. And then the cancer center statistician should be allocated for each IIT, and we are entitled to receive formal help. They get their own support. There's a cancer center fund for that pays for their time in terms of developing IITs. So we're not like asking them personal favor. It is agreement between our stat center and our cancer center.
Okay, her name is Masha Kocherjinsky, and she sent me a link here to fill out the form for our request. And can I click this link?
Wait. But there's a red cap form you can fill out to request Cisco support for study design. I'm copying. Yeah, so yeah, use that form to request formal help. Same thing for Haesung. Yeah, okay.
Yeah, so basically, if you click here, you can fill out all the forms for statistical help, like biostatics, like types of support, like sample size, like this. So no problem. So yeah, that is pretty much it for me. And now we are having a meeting. We just had a meeting with Lunit to make a paper about TLS, and we are having a meeting every Thursdays. And we are following up with Lunit with Dr. Isel.
So where are you guys with that?
So there I can show you this like Excel sheet.
Yeah. So every meeting, after every meeting, I know Dr. Isu is busy, so you should be giving updates.
Okay. So I'll share you right now. And this is apparently the Excel file that we should analyze. And yes, actually we had to subdivide the patient groups into according to the lesion of the biopsy, because one of the guys from Lunit told us that if you biopsy a lymph node, it can naturally look like a TLS. So because like we have to subdivide into lymph node group and non-lymph node group. And Dr. Isel wants me to run a survival analysis according to this lymph node and non-lymph node group. After this meeting, she told me to do that, and she wants to tell you that we have received visualization data from Lunit, and which is I'll show you that.
For those of you who do not know what this project is, from H&E slide, we're looking at tertiary lymphoid-like structure, TLS, tertiary. So there's lymph node, primary, secondary lymph nodes. We talk about tonsils, adenoids in our mouth. Those are all lymphoid organs. But inside tumor, there's the inside tumor, there's organ that looks like lymph node. We call it tertiary lymphoid structure. So if you have that in tumor microenvironment, what is the clinical implication? We are looking at that question with our own Northwestern lung cancer patients. Okay, show us.
Mm-hmm. Wait a second, please. Okay. So they gave us access to the scope program from Lunit, and I'm pretty sure this was what Dr. Isla was talking about. And it was so if you run this scope program, you can see the actual H&E slide in it. So and I have no idea how can I do this, and it says that my account is expired. So so she told me to tell you that we have the visualization data.
So what do you mean by visualization? I don't understand.
So it is basically an H&E slide, and the AI run the how to detect the TLS, and we can actually see the H&E slide with it. But I'm sorry that I'm also not sure what he was referring to about visualization data. So I'll ask her once more and update you.
Yeah, so my input is for the actual paper, the different TLS location, and there's ones that are abundant in TLS, there are ones that are not abundant. So the representative figures from the actual H&E slide, the whole slide image, as well as the high power field image, should be selected and represented as a figure in the paper. Okay,
Oh,
sure that
okay.
message gets across. Okay. Yeah, so the lymph node is really important. So definitely do the analysis and show it to me. So anything you guys discuss amongst yourself and the questions and the plans, you have to update me real time. Okay.
Okay.
I mean, it's ideal that Dr. Issa update me real time, but I understand she's busy. She can't be in the lab meeting, so you are the liaison.
Okay.
Okay, anything else?
That's pretty much it. Thank you.
Are you involved in radiomics too?
I don't think so. Yeah, I think Peter and Gian is the only involved in radiomics. So Dr. Gian led me to focus on this mixed response and projects with Dr. Issa.
Okay, Monica is the lead. She is medical doctor, so she'll be the lead for all radiomics. I know she'll be gone for a while, but Monica, if you can come to lab meeting or at least work with Hesong or Liam. So anything you do, give us update through Liam. So Liam is our manager. Hesong's our associate manager. So work with them. Whatever you do, update them. I know you can't be here physically next month, but you'll be here for the next 6 months. So you're the long-term lead for the radiomics project. You still work with Peter and Dr. Chion because they're the main. I think they'll continue to work on the project, even though they are not going to be physically with us. But you are the point of contact for this lab. So Monica, can you give us update on anything about the radiomics project? And first of all, do you think you got all the sign out you need from Dr. Chion?
Can you guys hear me? I'm sorry, I'm out with fever. Doing
Oh,
well.
I'm sorry.
Out in the lab, I'm sorry. For the radiomics, where I am now is that Peter, Dr. Chion, they have made a first set of data, which they've submitted to Dr. Yuri, and then they're running the database, right, Peter?
Sorry, could you say that one more time?
So we were discussing about where are we with the radiomics? And I was telling Dr. Che is that you and Dr. Chion have been already done with the first set of database, and that you're running with having meetings with Dr. Yuri and running the database, right? That's where we are. So there's that's what's happening with the first, and Dr. Chion and Peter have been working out on that. As for me, I just helped Dr. Chion with the manuscripts last week, and what we are planning to do is the major part is the segmentation. That's a little difficult part, and Peter is the one who actually knows how to do it, knows a lot how to do about it. So we're planning to make a video this week, right, Peter? If your schedule fits.
Yes. So I'll be filming a video on how to perform segmentations. And as for the first set of data right now, we're organizing it. We're almost done, and then we'll run the machine learning model as soon as we're done analyzing it. So
So in the meantime, we are planning to make a video to learn how to do segmentation so that it becomes a help for me and whoever comes after in the project. And I also have Dr. Chion's entire radio mix manuscript, sorry. What I would like to say is the Bible of everything, the very elaborate Google sheet where she has taught me a lot of my throat, I'm sorry. That's where I'm trying to learn through all of these things for now. I'm sorry, my throat is really, really bad.
I'm sorry. So yeah, so the goal is before Peter leaves, everything Peter knows, you should be able to do at Peter's level. And so even if they are away, you should be able to take the lead on this project. But since you haven't been in the lab for a while, I asked Haesung to help. So you're still at least you should. I know you haven't been involved in radiomics, but at least since Dr. Chion's not here, you should at least know the process. What's actually happening, what needs to be done, and if any new lab member comes, you should be able to teach them.
That is also my plan when I'm not around. I have spoken this with Liam as well.
Yeah.
In the background, although I won't be physically here, I will still be trying to like learn and still have communications, learn how to segment and everything, so that when I am back, I will not have anybody to like teach me. That's what my plan is for the time when I am gone.
Yeah. Good. And even if you're away, you can still work on manuscript writing. So yeah, you can still work with Dr. Chion on writing, and Peter is going to be involved. But Liam and Haesung, you can both help them because there's a lot of transition happening here. And Liam, you've seen it all, like when Jisang was here and even before. I think the pattern's been like a new person comes and then, oh, I don't trust their data, and then they start doing the data on all over again, and it's just happening too much, and it sometimes seems very repetitive. And so that's why a good sign out and understanding what's been done, what's not been done is so important. So can't emphasize that the good sign out is the key. And as a manager, at least you two need to know, what is the process when, and what needs to be done and how do you do it, like the manual, and make sure there's a good sign out, all that. So that's so important.
Basically going on Dr. Chion and Peter's footprints. That's all. We're going to keep it that as a standard for whatever next data we collect and whatever next we have to do.
Yeah, so we had the imaging trial call this morning. So this is because I'm just trying to think out loud, because Monica is gone for the next 2 months. So the MD who's going to be here is either Liam and Haesung, right?
And
So
Dr. Tegyu is here till end of August.
end of August.
And then Alan Cho, Dr. Cho is starting next week.
Okay. So they can all help, but they can't be the lead because they're gonna be gone pretty soon. So let's see. So So radiomics. So why don't you two work together? Just Haesung and Liam help out each other. And I know so the Monica is the lead, but because of her absence for the 2 month, we need a project lead for radiomics. So for radiomics, I think Haesung can help out, but really Liam, you guys both need to be in charge of where things are, kind of giving update. I know Dr. Jian will still be like academically involved, but I don't know her bandwidth. So she's gonna be seeing patients. So we would have to carry on this project. So let's do this for the next 2 months. Until Monica is here, Monica is the lead. Until next 2 months, until Monica comes back, Haesung will be lead and Liam will be co-lead. So Haesung, you're going to be giving us update on radiomics weekly basis for the next 2 months after, just in Monica's absence. But when Monica comes back, she can be in the lead. She can be the lead. It's more lead means you're the liaison between image trial, all the radiomics companies, all the Dr. Jian and Peter and Dr. Yuri. So develop relationship with Dr. Yuri as well. Monica, you as well. It's like so understanding where the project is and what things to be done, how to carry it forward, all of that. That Dr. Jian was doing that, all of that. But sort of Monica should be doing all of that while she's here. But yeah, I'll just have Haesung and Liam be the lead for all the radiomics, everything the radio. I mean, then you guys know the database, like 160 patients. It all overlaps with all immunotherapy outcome projects. So I think Haesung, you have similar project with heterogeneity and all that. So I think you're involved in the picture health and all that. So I think you're in a good spot to follow that up. But this is a great time to learn radiomic part, which is segmentation and how do you upload and do all of that. So and then the image trial as well. So yeah, and then Taegu and then Alan, all of these people can and help as we have deadlines, we have some things to come up, they can always help. And then of course the students can help and all that. So let's just have that as a plan. So anyway, the manuscript that needs to be written is the one Dr. Jian talked about. And I know Peter's working on it as we speak. So let's wait for the result and write that up. So it will be the first radiomics paper from Northwestern cohort. And my hope is that, I don't know when Edwin's going to give us the next batch of patients. But with that, we will, we'll do analysis too, but I don't think we can wait. So that's why I said just write the first batch. Okay. So Liam, where are we with all the other imaging companies?
Yeah, so Picture Health, we've sent over all the data we have. They're working on their side. They said they'll keep us posted with any new results or outcomes. And with them, we are obviously Dr. Haesung's in charge, but we are aiming for a couple of abstracts for the upcoming AACR deadline, which is going to be in November. And then image trials, we had the meeting today, and then our lab members will have a training session with their technician to learn their program and start using that tomorrow. And then Imagine AI, we have a meeting tomorrow to discuss the next steps on our projects with them.
Who's coming in?
For
the image trial. No, I'm saying who's gonna get trained?
Oh, so Dr. Taegu is going to be in charge until now, until like Dr. Cho comes in, and then we'll probably hand that project over to Dr. Cho when he comes. And I've also included the undergraduate students so that they can learn the process as well.
Okay, so let's do so all of them, all of the undergrads? Or
Believe so. Dr. Tegu, do you remember who I put on that invite?
The email you're talking about?
Mhm.
I'm just checking your email.
image trial?
Yeah, so here I put all of the students that we have right now.
Okay, yeah, the more the merrier. You guys should learn what this project is. So take you have to tell them what it is and why we're doing it. So the whole idea is put everything in the cloud so you can manage the whole project. So and you know, so you have to teach them what is resist, why are we doing this, and you know, why is image trial so innovative, all of that. So
I see.
okay, so I say after Peter's gone, Monica and Haesung, you'll be the contact for Dr. Yuri. So make sure you guys meet with him on regular basis and sort of touch base as Peter's doing. Okay. Okay. Haesung, you want to give us update?
Before we begin, I just wanted to make sure that this radiomics data set doesn't have any patients who receive IO as adjuvant therapy. Is that correct?
Right,
No.
no adjuvant therapy.
Right, like Monica or Peter, Liam, or Dr. Tiki. Because that's what Dr. Chion told me, but I'm getting confused now after Dr. Tiki's presentation. So I just want to make sure there's no patients with adjuvant therapy, adjuvant IO.
Dr. Tegu, do you know?
Yeah, as I mean, as like Dr. Haesung told me, yeah, I'm also confused. Like, yeah, there are patients with only chemotherapy, right? As you
Well, chemo and the VEGF inhibitor, so I think you'll have to go.
So it's
Maybe we should double check with Dr. Chion.
okay, yeah, I'll make sure to double check the cohort. Like, I was also confused about this, so the best approach here is to like double check every regimen they received and to make sure that
I mean, you can do it yourself too. There's, go through only the stage 3 patients. Stage 3A, like 3B will most likely be
coming up, but
stage 3A.
Or-
Ones that just say, just make sure they didn't get any,
are they
just make sure they didn't get any.
understood.
So it should be all recorded, right? Like what stage and what regimen they got. And that's why, you know, whoever looks at the chart for the first time annotates it all so that we don't have to go back.
Yeah, those have been recorded. It's just that we're not sure if the stage 3 patients are actually the unresectable patients.
My understanding is not, but you can ask and check.
Yeah. I can start my updates. So yeah, today I will get the protocol from Dr. Teki and start working on the STQ project. And then for DART, we're still waiting for the thyroid feedback from Dr. Kurzrock. I have finished working on the cohort 13, and so as soon as we get the thyroid feedback, maybe, I mean, you can decide on the timing, but I can hand over the cohort 13, which is a non-epithelial ovarian cancer. Let's see. And then yesterday and over the weekend, I worked with staff with his early stage squamous and adenocarcinoma paper. And then And then I also worked on last week and also partially weekends. I worked with Dr. Chitaro on the COVID cloud project. I haven't heard back from him, so I'm not too sure about which. Yeah, so I just gotta confirm a few more things before I start extracting data from using data. So waiting for that, and then I will also have to start working on the World Lung Cancer poster. For that, I will have to rerun the entire analysis because remember looked at the raw data again and did everything all over again. So yeah, that's that. And then for picture health, I have to go through our Excel sheet again and then just make sure. Like a lot of them did get their biopsy done outside of Northwestern system. So I will, Monica and I will work on like contacting each hospital. But so like, for example, patients would get their biopsy done outside of the hospital, but they would get the surgery done at Northwestern. And so, I mean, ideally, it would be nice to get the outside hospital slides, but then I made sure to request the Northwestern slides as well. Initially, we excluded all those patients, but I made sure to include them so that we get as many slides as possible. So anyways, like Monica and I worked on editing the Excel sheet that we'll be sending to Dr. Alexiev so that we get the full like slide list. And so I just sent that
Like,
email.
Patients
then,
who
yeah,
also were
we'll-
there for like second opinion, right? We had good set of
Yeah.
patients who were just for the second opinion and nothing was done in Northwestern. So we're trying to get those as well, right?
Yeah, we'll work on that. And then for Tempest, there was some mismatch between the Tempest ID numbers and the X3 like the accession numbers. But anyways, staff worked on it, communicated with Jen, and we like from the radiomics data set of 209 patients, we were able to find that 66 patients had Tempest IDs. Among them, 61 patients had DNA and CNV data, and 37 patients had RNA data. And that's the unresectable stage 3 maybe, and then stage 4 patients with any lines of therapy for IO.
So yeah, RNA is RNA. So just once we can do the heterogeneity analysis, we should run it, and you should learn from stats how to run it. And then, those are the people who received immunotherapy, right?
Yes.
So in that, so the project is in that patient who we have heterogeneity data. How does that impact their survival outcome or everything, clinical outcome? Yeah, clonal versus a lot of subclonal. How we looked at the RISV paper, and can we replicate that? And then there are many different heterogeneity indexes. You can use the Shannon's index, so use different index and then see if any of them have any not only prognostic but predictive value as a biomarker.
My question is, the PyClone way can't distinguish between clones and subclones, is that correct?
It's hard to tell, but
Yeah.
it depends on the threshold, setting threshold. So, how many times you run it, stats will tell you all about it, but there's a lot of subjective things, but still it's a way to tell us if there's many clones versus not many clones. Very broad.
Right. Yeah,
So-
from its first run, the maximum number of clones we got was 9.
Okay.
Yeah.
So yeah, keep working on that and show us any preliminary results on that. And then that's going to be similar to the TAP program, right? When we get all the data from Tempest, and that's not Northwestern data, so. Yeah, so that's, you know, everything you learned from this project, you can apply to the TAP program,
It just won't be RESIS based.
right? So just based on the, you know, clinical chart, you know, time to next progression, you know, change in therapy, we will have that as an endpoint, yeah.
And then finally, the last trial, still waiting from Arquizo, and then Agenus, still apparently still in review, and then Zencor hasn't ever responded.
You send
That's the
email to
final
them,
update.
or they're just ignoring us.
Yeah, I think so far I've sent like nearly 10.
That is so odd. Yeah, I don't understand. But anyway, let's just follow up on Akizo like a weekly basis. Because we want to move forward. And you know, is there anything you need from us? You know, we can send you the protocol, you know, what do you want? You know, we just yeah.
Yeah, we got an email from Pan yesterday. Would you like to respond
Yeah,
to this, or I?
Yeah,
respond
can you
to-
show me?
I'm not sure. Oh yeah, sure. This one.
In discussion with clinical team to review study design in detail, I will try to coordinate internally and explain it. Okay. Let's wait then. Yeah, we just say, you can say thank you, we'll wait, you know, wait for your, you know, update, something like that. Yeah, that's fine. Yeah, so that's kind of our priority. Yeah, next.
That's awesome for now.
Oh, updates on DART papers, where are they?
Yeah, there are papers, still waiting for feedback from Dr. Kurzbach about the thyroid one. Cohort 13 non-epithelial ovarian is all ready to go for circulation, so we can maybe wait until Dr. Kurzbach responds with thyroid and then send it off.
So Dr. Che, I think Dr. Kurzak actually sent her feedback in yesterday to you directly. There was a separate email mentioning that she had sent it to you, so if you could check and forward that.
Okay.
I'm so nervous.
She
And
sent
the other papers, what?
Yeah, they're almost ready. It's just that it's taking time, like cutting down the reference numbers. But that's pretty much it. And they're waiting for the risk table for just one cohort.
and Patricia was asking that we kind of space this out because she's spread thin with the other submissions at the moment. So she prefers to do these one at a time.
Okay, let's talk about that. Yeah, I'll forward it to you, Haesung.
Thank you.
Okay.
You see a lot
And
of
then
red
other
here.
manuscripts. Yeah, just send it. You know, the very final version as they come, just show it to me. And yeah, I will approve it real time and I will send it to Kurdrag and then you guys can send to Patricia. That's fine. But for Kurdrag, I think she just wanted to interact with me directly, so because there's like sensitive authorship issues and all that, so I understand. Okay. Yeah, so again, DART papers are priority. All the papers you're involved, we get them out first, send to Dr. Kurdrag, all of them first. But of course, you know, the trial proposal, all of them, they have deadlines, so we have to meet those deadlines, but if it competes with any other projects that are not like real-time deadline submission, then the dark paper is priority.
Yeah, I will send you 13 right after this meeting, and then I will start working on the STQ proposal.
So just print it out, because I'm, you know, I like old way. I need to be able to give you my last comments.
Okay,
Yeah, and then you fix whatever in my comment is, and then just send me the final version and I'll forward that to Kurdra.
okay.
Okay, anything else?
That's all.
Okay. Okay, Grace, tell me what you've been doing last week.
So, uh, so me, Will, and Jessica were given the EDW screening project. So we're just screening all these patients that have lung cancer, and then writing all their data into Excel sheet. And then I also interviewed Dr. Iser, and I'm editing her video. And we also are working with Sally and Dr. Yoonhee with their manuscript, and we're drafting it right now.
Okay. Good. Jessica?
Yeah, pretty much what Grace said. We've been working on the same thing. I think Sally said, so Sally's like kind of distributing parts for us, and yeah, Dr. Uni's busy, so we don't know like when everything will be ready, but yeah, we'll keep you updated. That.
Okay. You know, I guess, you know, you guys can learn from these projects. I mean, to me, it's a very small project and it's something that, you know, you sit down, you can write it up in a day or two and submit. But you know, we have Uni who's extremely busy and Sally's busy too. You guys need to learn. So, you know, I think it's good for learning experience. But you know, to learn, you have to kind of understand why are we doing this, why this topic is important, you know, what does that mean? What is this algorithm? So you can learn as much as you do background reading. So it's for your learning and just be a part of the team. And you know, what does it mean to write up a manuscript? But as far as if but if you look at the efficiency standpoint, you know, the main authors need to sit down and just write it up and just submit it in the next couple of days. To me, that's more efficient. But I still think it's a good opportunity for you guys to learn. But as you help them, just make sure you know, you guys kind of have your own internal deadlines and people finish on their agreed time, and then you have time you know, when you're going to submit, and then just keep, you know, just push for the deadline. Otherwise it's like, oh, I've done my part, I'm still waiting, and like every week it's going to be, I'm waiting, she's busy, he's busy, and we've seen that too many times. So we have to have like internal deadline, and this is how you like, how do you do a teamwork? Like this is like reference letter season. So I'm like, I'm writing this letter, and a lot of the, oh, he's a team player, he's like get things done, punctual. But in reality, like where are things like, oh, I'm waiting for like, oh, I've been busy with this, and you know, like, and then do you take it all the way? Oh, I just help with this, and you know, and you know, it's hard. It's super rare to see someone who's really persistent, who really keeps promise, and who actually delivers. So understand it's a rare quality, but strive for that goal. And you know, working as a team is, I think, 10 times harder. If it's your own project, you know, you just do it yourself, that's it. But if you work with many people, like you ask and then you wait for their response, they don't respond. And then like you're kind of at loss. And it just, a lot of people get bitter, because of bad experience doing collaboration. So this is in a way survival tactics. Like how do you make this team functional and get things done, and no one gets angry because you get more credit, I did less work, you did less work, and what is being fair to each other. I cannot spoon feed you on all of those. And this is not something you're doing to get or you can get credit for what you've done, but the whole idea is a learning experience. Even if you don't get any credit, this is a valuable learning experience. So just learn to get internal reward in the process. Otherwise, you're gonna be more frustrated as you do more team projects. I can guarantee you that. So you have to have good communication style, and really have habit of good team building. And that's why it's so important to be in the same space, because it's really hard once you try to do everything online. Okay, so keep the project moving forward. And then Liam, you have the pacemaker's manuscript. We should really publish that, and I know you and Grace Lee have been writing it.
Yes.
So again, if you need any help from them, I think it's a paper that should come out soon. And I know there's always priorities, like move this project forward. And you can see the clinical project always trumps. You have a patient waiting in the room, like what else can you do? Like everything comes later. So I understand that. So that's why we have people in the lab doing things. So make sure those projects are well distributed among students. And let's still not forget that project, because I think it's a good project for students.
Yes. So actually, I've asked Jessica to help us finish writing that up. I
Okay.
discussed with Grace, and we're both on board and an agreement that it would be great to have Jessica help us kind of put in the finishing touches on the writer process. So she's been given all the essays and all the codes that we've used and all the previous abstracts and the draft that we have currently. So she's working on that as we speak. So that should be, that with the goals to finish that during the summer as well. And then for the variance classification also, like I was able to catch up with Emma, with Grace, Lee, and then Eileen and Sally, just to touch base on where all the different projects are. So as Emma mentioned, the first one that Eugene did has been submitted. So hopefully we'll get a positive response and be done with that one. Emma is finishing up the second one. And then the third one is the one that Eileen and Grace was working on, which is now with Eileen and Sally.
Okay.
So they've been told to finish their first draft in the next couple of months. So I've told them maybe the first or second week of August to come to lab meeting with their first draft, so we can go over that with you, and then we can provide feedback with, again, the goal to submit by the end of August. And
Good.
then Dr. Yoon Sally is working on the fourth iteration with Jessica and Grace's help as we speak, with the same deadline in mind. So the goal is to submit everything by the end of August.
Okay, very good, very good. Good. So let's keep track of it. And then we do have, I think, Google Doc or the Google Sheet, where we have project name and project lead and the publications, or where it has been submitted to. I know we were keeping track of that. So Liam, you are in charge of all that. So let's keep track of that, write the title name and the lead authors and where it has been submitted to, get all that information, and send me that link to the publication project, like where things are. And let's try to update that, with every lab meeting. And kind of go through that together, so that we can kind of visualize and see where things are. So you should continue to be in charge of like the publication, meeting deadline, who's doing what, as a manager.
Mhm.
Okay. Today, what do we have at 3 o'clock?
3 o'clock is going to be our book club. It will be the last chapter of Inspired.
I see.
And then we still have updates from Will and Peter.
Okay.
We haven't heard.
Okay.
Emma. So Emma will be coming to see you in person today at 12 after the lab meeting. And then we're also going to have Jessica and Peter do your faith-based interview later today at 4.
Okay. Okay, we'll talk about that. Okay. Liam, do you have updates on the projects that you're following?
Yes, so I just have a couple of things. First of all, and this one I'll show you in person, but I've updated our DREAM protocol to include third cohort for the patients who are getting double lung transplant for respiratory failure. And I've kind of kept it vague, and I just included all the indications for the classic double lung transplant, including pulmonary fibrosis, COPD, things like that. But then I wanted to talk to you mainly about the cohort size. So I don't know if you want to split the current cohorts or if you wanted to add more patients. I was presuming that this cohort, the third cohort, cohort C, would gain a lot of traction just because there's more indications for it and it's more common. So I don't know how we want to go about the sample size, like the cohort size of that. Because right now we are doing 10 patients for cohort A and 5 patients for cohort B every year. And the total size is 75 over 5 years.
Okay.
And I don't know how we're going to trend, but we've been accruing patients really fast. So I feel like we're going to reach the limit pretty much earlier than the 5 years.
Yeah, so right. So usually when we get to the half, when we are going to over accrue, we can change the sample size. It's easy. But my expectation is this is gonna be similar to the active lung cancer patient recent history, right? So this is going to be, I think it deserves like same amount of patients.
As cohort A?
Yeah,
that's what I was thinking.
So yeah, change to that and get Dr. Barat's final approval. Yeah, and that should be good. Yeah.
So I did put that into the draft. I'll just print it out and show it to you in the afternoon today. And then just one small thing that I did want to bring to your attention was an email from Janssen.
Yeah.
Let's pull it up. This was regarding the educational sessions.
Yeah.
Let me just share that email with you really quickly. So this is the email. This came in, I think 2 days ago.
Satellite staffs on understanding what we do in Pacific. I don't understand their question. Satellite staff.
So it sounds like the satellite staff, like the locations, are just not understanding what we're trying to do. So they're not sure what this is about or how they can help.
Hmm. Okay. I have to think about how to respond to that. Yeah, but
Mhm.
yeah, okay. I will. It's from Janssen Oncology or Janssen. Okay. Anyway, let's when you come with the let's just think about it and respond together.
Sounds good.
Okay. Anything else?
No, that's it for me for now.
Oh, when
So
you think the trial will open, it's taken too long, the biomarker.
no. So they're all sent out. So we have a couple of meetings coming up early August because some of the companies wanted to talk about the details of the agreements.
Uh-huh.
So we have that. Yeah, I think we just need to kind of iron out the kinks on the agreement and get everybody to sign, and then we'll be good to go.
So what company is done? Like, or are we not, no one's like finished signing or?
So last I heard, all the companies said they are going to review it with their legal teams and then get back to us. That was like last week. So I think I can circle back with them and check with our agreement department as well.
So check with all the companies on weekly basis. I know you made like the chart.
Mhm.
So let's just really track them down. Like,
Right.
you know, we need to open it. We're just say we are planning to open it, you know, in end of August. And with that deadline, let's really work together. And if there's anything you need from us, let us know. They, you know, just send that kind of email on weekly basis, teasing me.
Mhm.
Yeah, because like we waited too long. Like I feel like
Yeah.
we did it for this 2 years, like since you were here, you know,
Pretty much.
and it's just so yeah. Yeah. Okay. Anything else?
That's it for me for now.
Okay. So Will, any update from you? Anything? Tell me about what you've been doing last week.
Yeah, so I worked on the same thing with Jessica and Grace. We're still working on this EDW thoracic oncology patients Excel sheet. We're updating there are like a lot of patients we have to catch up. There are like 26,000 patients that we have to record from 2018 that 2020 I believe, and we're catching up until the recent patients. And we finished reading all those this last week. Yeah, and that's pretty much it for on my side. And also I'm trying to schedule an interview with Miss Wilderness's sister-in-law to get the pacemaker interview done. Yeah, that's it on my end as of now.
Hmm. So same thing. So this is so if she wants to talk about her faith, it would be another interview. But you could do it at the same time. You just record it differently so that we don't have to edit it. So there's faith-based questions. There's just regular health, the pacemakers question. So I know for her, faith is very important. So you could do 2 different videos in the same way. Okay. Dr. Tegyu, can you do your presentation?
Okay. Wait a second, please. Can you see this?
Yeah,
Okay, today I would like to have a presentation about clonal hematopoiesis of indeterminate potential, which is CHIF CHIPS. CHIP is the presence of clonally expanded hematopoietic stem cell caused by a leukemogenic mutation in individuals without evidence of hematologic malignancy, dysplasia, or cytopenia. So CHIP is associated with 0.2 to 1% risk per year of leukemia. So CHIP is often considered a pre-malignant lesion of leukemia and MDS. A lot of studies demonstrated a twofold increase in cardiovascular risk for those who have CHIP in their genes and their mutations. And roughly 80% of patients with CHIP have mutations in epigenetic regulators, which is DNMT3A, TET2, ASXL1, which accounts for up to 80% of all CHIP mutations, and DNA damage repair genes, which is PPM1D, TP53, and the regulatory tyrosine kinase gene, JAK2, or mRNA lysosome components, which is SFF3 and SRSF2.
okay, go back. So Dr. Taegyu is going to work on this project, but when he leaves, Dr. Haesung, you'll be the point of contact for this project because it has so much to do with Guardant. So whole idea is I want to tell you guys, I ordered Guardant, which is the circulating tumor DNA panel. And I order it all, pretty frequently, and it's very sensitive assay. And then a lot of times it will show up with TP53 mutation, DNMT3A mutation, things like that. We never know whether it's coming from tumor or bone marrow. Okay, why can they show up in bone marrow? Because bone marrow, you have a lot of hematopoietic cells and they circulate in your blood and they will contain random mutation that can happen. And as you can see, 1 out of 100 patients will have leukemia because of those mutations. Okay. So, cancer is a genetic disease, not hereditary disease. Some are, but very rarely. But it's a genetic disease in a sense that it requires DNA mutation. So the mutation sometimes will be tumor suppressor gene or driver gene or just epigenetic regulators. Does not matter. But if it happens, it will confer our normal cell immortality. Cancer cells live forever in the right situation, but the host dies. Cancer grows, sucking up all our nutrition, destroying all our organs. That's why we humans die of cancer. So cancer dies together with the host because it's an immortal being. Okay. Anyway, it all starts with these random mutations. And why do mutations occur? It's a random error. Okay. As cells divide, what happens? There's an error. There's a mistake happening. And how do our body respond to that? They have DNA repair system. And as we get older, just like an automobile vehicle gets, wear and tear and it breaks down, our body does too. So, our DNA repair system gets old too. They are not error proof. So the more mutations you see in the bone marrow means there's a risk. But what's interesting is not just leukemia risk, but there's a cardiovascular risk. If lung cancer patients gets chemo, but then they have CHIP, clonally expanded hematopoietic stem cell, then they're gonna have higher chance of getting toxicity and higher severity in their toxicity. It's a very interesting concept. But what's interesting is we can really analyze our own Guardant data, looking at all these mutations and try to figure out because there's an algorithm to say what's chip, what's not chip, because you can't never say that for sure. And our interest started really by Albert Curie, our first lung transplant patient. And the why we're interested, because before and after transplant, his TP53 and all these mutation levels have not changed. Before and after, these mutations are exactly the same. If his lungs are filled with cancer before we gave him new lung, if lung was indeed the source of DNA shedding, then it should not. It should be dramatically different before and after circulating tumor DNA, but they are exactly same. So to me, whatever many mutations that were picked up before transplant is probably all bone marrow, because chips will be detected by blood only ctDNA MRD, minimum residual disease assays, but it will never be detected by the tissue informed MRD assay. Okay, do you guys know the difference? Tissue informed is you sequence tissue, and only the mutations that were found in the tumor tissue will be sequenced in the subsequent blood assays. So you're not going to be able to detect chip. You're only detecting what was in the tissue, right? So that's called tissue informed, and the company that does that is called is Natera, and their product is called Signatera. Okay, so I'm running Guardant as well as Signatera in all of my double lung transplant patients, but I'm also doing that in many other patients as well. So we're in a great spot to ask this question: what is the clinical implication of chip in our own population? So this is a very interesting topic that we like to delve into. Very clinical question. Okay. So chip is, everyone should know what it stands for: clonal hematopoiesis of indeterminate potential. Indeterminate potential means we don't know what it is. That's what it means. Clonal hematopoiesis, it's a bone marrow hematopoietic cell, but it contains clonal mutation. That's what it means. So that's what chip means. And the more if you have more chip, your body seems to have more inflammation, and that's kind of the theme here. Okay, I just wanted to explain you why this project is really interesting. So Dr. Taegyu will be lead, but after he leaves our lab, he'll still remotely be involved, but Dr. Haesung will take over. Okay.
Okay. This is a general definition of chips suggested by Stensma in 2015, and chip should be an absence of morphological variation in blood cells, and a candidate driver gene mutation should be present at variant allele frequency at least 2% in peripheral blood, and it should be an absence of diagnostic criteria for hematology malignancies. So most studies have adopted this 2% VAF threshold for identifying chip. However, this threshold is somewhat arbitrary and was initially determined by the standard limit of detection of NGS technologies. So the recent new technologies such as error-corrected NGS and the ability to detect lower VAF clones, less than 2% VAF clonal hematopoiesis appears almost ubiquitously in younger populations at age 50 to 70, reaching rates of 95%. These are some examples of chips. So DNMT3A is a methyltransferase enzyme, and TET2 is also an enzyme that takes part in DNA methylation, and ASXL is an epigenetic modulator, and JAK2 is cellular signal transmitter, downstream cytokine receptors, and TPM1D and TP53 are both DNA damage response pathway genes, which has a role in repairing DNAs. And as I mentioned, SFF3B1 and SRSF2 are mRNA spliceosome complex components. But most importantly, there are a lot of chips without candidate driver mutations because of limits of detection methods, epigenetic changes, or usual drifts, or mosaic chromosomal alterations. So these are some studies about chip without candidate driver mutation. And the first, whole exome sequencing of peripheral blood DNA from 12,380 Swedish patients was among the first to identify the large fraction of clonal hematopoiesis carriers do not carry obvious driver mutations. And the second study, the whole genome sequencing of 11,000 patients, the majority of subjects with clonal hematopoiesis did not carry a clear driver mutation. So it is difficult to define and identify CHIP. This is the mechanism of cardiovascular risk of CHIP. Several studies of clonal hematopoiesis have characterized a hyperinflammatory environment, including such interleukins like TNF-alpha, interleukin-6, and interleukin-1 beta through the activation of various inflammatory pathways. A primary consequence of I'll just say CH-associated inflammation, and one of the main drivers of increased morbidity and mortality in CH carriers are elevated risk of developing thrombosis, early onset myocardial infarction, and chronic heart failure. So here you can see that TET2 and JAK2 and those CHIP genes are resulting in these cardiovascular outcomes.
Wait, go back. So what is the magnitude of the risk?
In general, it's twofold, like twofold, 2 times more likely to develop cardiovascular risk.
So do you know why those TNF alpha, interleukin 6 and 1 beta are activated through CHIP?
I researched on the the molecular mechanism of this CHIP genes, and it is due to the activation of the NLRP3 inflammasome, and the exact mechanism is not well known, but it is generally due to the activation of inflammasome, and the precise mechanism is not well known.
Okay.
So in the context of cancer therapy, CH has been observed in the context of a wide variety of solid and liquid malignancies and often considered to be consequence of cytotoxic chemotherapies. So cancer therapy with radiation, platinum, and topoisomerase 2 inhibitors preferentially selects for mutations in DNA damage response genes such as TP53 and so on. And targeted therapies and immunotherapeutic agent exposure were not significantly associated with CH. This is another study done in cutaneous melanoma, and the regimen was pembrolizumab and nivolumab and ipilimumab. So immune checkpoint blockade did not appear to be associated with expansion of clonal hematopoiesis. This is the same result. So the ICI agents were not associated with CH. So this is about the presence of CH in patients with solid cancer. Among 200,000 individuals in the UK Biobank, CH, especially with mutation of VAF, more than 10% was linked with incident lung cancer, kidney cancer, incident risk of lung cancer, kidney cancer, lymphoma, and sarcoma.
So these
And
are
this-
patients with solid cancer.
It's just, yes, with solid cancer.
So this is cross-sectional. This is not saying CH before diagnosis of cancer will lead to future lung cancer. This is like cross-sectional. Like in lung cancer, there were a lot of CH chip. That's what it's saying, right?
Yeah, exactly. This is the cross-sectional study. There's no causal implication of like how CH impacts in solid cancer.
Okay.
So this notably, and like certain driver genes were also carried on their own incident risk associations, and DNMT3A were associated with stomach and bladder cancer. And this SF3 and SRS genes were uniquely linked with higher rates of colorectal and head and neck cancers. So this is another study done with more patients, 628,000 individuals from the UK Biobank, and the CH had an increased incident risk of lymphoid cancer, lung cancer, and breast prostate cancer. So there are a lot of studies that CH is linked to lung cancer. Okay, there are a lot of papers that mention clinical effect of CH in patients with solid cancer. This is another study with the opposite results. And this study had an analysis in metastatic colorectal cancer and was able to focus primarily on CH and outcomes in metastatic cancer, finding that 36 of the patients in the trial had CH, and that CH was associated with improved survival outcomes. And okay.
So why improved?
So I had another slide that mentioned that the CH is related to poorer survival outcomes, and which comes to the conclusion in the box below. And there were a lot of studies that mentioned that CH is related to poorer overall survival outcome, which is our common sense. And this is quite the opposite of our common sense. That there was a paper that showed the better overall survival with CH patients. And the conclusion of the clinical effect of CH in patients with solid cancer is that current knowledge of CH in solid cancer depicts the relationship that is as heterogeneous as cancer itself. So more research will be required to better understand this relationship to determine the context of where CH is helpful, harmful, both or mutual for patients with solid tumors. This paragraph is from a review article, and it is quite positive that according to our current knowledge, it is not sure how CH impacts on solid tumor.
Okay.
This is the cellular mechanism of CH in patients with solid cancer.
Go back. I have comment. So FIRE-3 trial is a pretty famous colorectal cancer trial, and it looks at FOLFIRI, which is 5-FU, irinotecan, and oxaliplatin, plus cetuximab versus FOLFIRI plus bevacizumab as first-line therapy for patient with metastatic colorectal cancer. So phase 3 trial, and the objective response did not significantly differ between both regimens. The association with longer overall survival suggests that FOLFIRI plus cetuximab could be the preferred first-line regimen for a patient with KRAS exon 2 wild type metastatic. So if you have KRAS mutant, then cetuximab doesn't usually work. So anyway, it's a famous trial, but it's used chemo, traditional chemo, and cetuximab and bevacizumab, you can think of them as a targeted therapy, which does not affect or is not affected by CHIP, but the chemo was. But I don't understand why people with CHIP would have improved survival outcome in this specific trial. And was this improved survival outcome happening in both arms? Like, I guess in all every participant, I guess. Did the
I
authors propose a potential mechanism of action? Or they say we don't know why this happened?
according to the review article, they just said that we don't know why this happens, and I didn't get
Yeah,
into
why don't
that.
yeah, why don't you read the
Mhm.
article itself and see maybe the authors in the discussion said something about
Oh,
why this happened, and that might
mhm,
give us a clue because they really thought hard,
mhm,
as
mhm.
a primary investigator. So let's think about that. Okay, but you can move on for now.
Okay, thank you. As I mentioned before, this is the cellular mechanism of CH in patients with solid cancer. And interestingly, there is evidence that patients with solid tumors with CH experience elevated levels of lymphocyte invasion in the tumor TME. So this is one study, and another study stated that
So the other thing we can look at, Haesung, this is relevant to you as well, and the LUNIT studies as well. So indeed, if the tumor microenvironment has more levels of lymphocyte invasion, that's going to be reflected by the TIL score, by the LUNIT scope score. So we have all of that data, and Taegu, you have that data too. So we can look into patients who have the LUNIT score, and then look at the garden data and see if from the garden data, you have the definition. So tease out the CHIP data and see if there's more CHIP in patient who has higher LUNIT score. So that can be looked at as a side project. If this hypothesis is indeed true. Okay.
Mhm.
So follow up
Okay.
on that should be just a few patients. Okay, because right now I think we have LUNIT. How many LUNIT patients do we have, Liam? Do you know?
LUNIT, we have, I believe, 60 to 70, and then
Yeah.
we're getting more
And
because we requested more from Dr. Alexiev.
right, Haesung, do you know how many we requested?
The request
It's
is
122
22?
after excluding some patients, yeah. Yes. Initially it was 138, but then some patients just didn't have any slides, and then or it was only cytology, which we can't do an HM side by staying on.
So we requested how many?
100. I can get the exact number if you just give me a bit.
Yeah, but just ballpark. 120?
Yeah, about that. And then we're gonna try to obtain more slides from our play hospitals, but that will also take some time.
Right. So 60 was the prior one, and then we requested 120 more.
Previously it was 55. The duplicates were 55, and the non-duplicates are 120 plus.
125. Okay. Okay, let's hope we can. And Dr. Alex said he'll work on it, right?
Yeah.
Okay,
Very busy. Okay.
When he has time.
yeah. Okay, but you know, in that 55 patients, we probably, some of them probably have garden. So you can kind of look at them, Pegu, who has garden, and then see if some of them have chips, okay? Okay, go ahead.
Yes, as I briefly mentioned before, and TET2 and PPM1D was related to increased interleukin-1 beta and interleukin-18 via increased activation of the NLRP3 inflammasome, and the precise mechanism is not well known. And interleukin-6 is another commonly elevated inflammatory markers in CH. It's linked with both tumorigenesis and anti-tumorigenic processes. So the conclusion here is that at the cellular level, changes to immune function induced by CH driver mutations have both pro-tumorigenic and anti-tumorigenic effects. So as you can see in this figure, there is some systemic effects of CH, which is chronic inflammation, and it can also cause therapy-related myeloid neoplasms and age-related diseases. And tumor level effects have like diagnostic interference and invasion of the TME and cancer-specific effects on tumor progression, modified immunotherapy responses, potential cancer-specific protective anti-tumor immunity.
So the modified immunotherapy response is what we're getting at, okay? Because that's the whole data we generated. Okay.
So we had the research on the relationship between CHIP and lung transplantation. And there was an article, a very recent article that had a research on prevalence of CHIP before getting lung transplantation. And CH and DDR genes like PPM1D, ATM, and TP53 is prevalent in lung transplant recipients. And they wrote a reason for this in discussion section that genetic carriers of telomere biology disorders have an increased risk of developing both ILD and CH, and ILD is a candidate for lung transplantation. So this like gene disorders might have an impact on both ILD and CH, so that the lung transplantation cohort in the lung transplantation cohort, DDR gene was prevalent more than in control group. So
Wait, go back. So did they look at all transplant or just ILD or?
Just all the lung transplantations, regardless of their illnesses, like ILD or so on.
Okay, so I think our patient Albert Curie belongs to this group. Although he's all cancer, he's not ILD or he's cancer, but he does have a lot of DDR gene mutations that look like CHIP. So I guess so is this undergoing, this is before transplant. Did anyone look after transplant?
Also, this goes to the next slide, and they looked at if there's a change in CHIP during immunosuppression for lung transplantation, and at the time between longitudinal samples span the most intense immunosuppression period during the first 6 months following transplant, and the variant allele frequencies, including both DDR and non-DDR, so all VAS, were mostly stable over that time. So During the immunosuppression, there was no, there's minimal change in CHIP genes.
Minimum change, okay. Okay,
So I was interested in this, how immunosuppression affects CHIP, and there were no other data regarding the change of CHIP genes during immunosuppression, because the article I mentioned right before was a very recent article, and there was some article conducted among ANCA-associated vasculitis patients, and they all received immunosuppressive therapies, including steroid and cyclophosphamide, and the result was the same. The prevalence of CHIP was not higher among patients who had received immunosuppressive treatment prior to sampling. So it seems that immunosuppression doesn't affect the CHIP genes.
and then this was proven by, was this a one paper thing? Or
Oh,
other-
this is just a one paper, and because the article I mentioned from here to here is also recent. Like it just came out last June, and it was so recent paper that there was no review article tackling this matter. So
Okay,
I was just like yeah, okay, and this is an article about the clinical outcome after lung transplantation with patients with CHIP genes. So CH and DDR genes was associated with post-transplant outcomes, including CMV activation with p-value of 0.018 and mycophenolate intolerance with p-value of 0.031. So this is the result.
what about overall survival, recurrence, rejection, any of those big outcomes?
Um,
I'm sure they
those
look.
like this was the whole results section of this paper, and I think that they didn't look into the survival data. If you want to look, like there's a paper right below for the reference, and I don't think that they checked those survival.
So
data.
after the lab meeting, just print out the whole paper and
Mhm.
let's find if they did the analysis and yeah, why don't you look at it and let us know? But
Okay.
after this meeting. JCI Insight is a pretty good paper. So you see, we come up with a question and you look
Mhm.
at the literature and someone asked the exact same question and just published it, right? So this is the world of science. Like, it's not only you. If you think of a question, someone really had the exact same question and they can, they looked at it. So I think it's amazing that people are doing this. But in terms of ctDNA change, as well as the CHIP change in lung cancer, lung transplant, I bet no one has looked at it. So you could definitely look at it later on. But I think go back to your slide before the transplant.
These are all before transplant. They're okay. Yes.
Before this. So, like I said, there's a modified immunotherapy response. So I don't know how this happens because CHIP is not affected by immunotherapy, right? Not affected, but chemo does affect it, as you can guess that the chemo destroys DNA. DNA damaging agents are a lot of chemos. And then with chemo, your risk of stroke, heart attack, all of those goes up. but it doesn't go up with immunotherapy. However, CHIP can modify immunotherapy response. I don't know how. So the next question for you is, how does that happen? What is the mechanism of action? Two,
Mhm.
what is the preclinical and clinical evidence that shows that effect? And then thirdly, can we look at that in our own lung cancer cohort? So we have our own lung cancer patient treated with immunotherapy. See who has garden. So this, you have to work with Haesung. So Haesung knows who has garden. And in the garden, because we're going to look at heterogeneity anyway, that's our project. But in addition to heterogeneity, can we look at CHIP? Okay, so work with Haesung to come up with our own way, just using the garden data. Can we come up with identifying what's the CHIP in our patient? Okay, and sort of build that database. So in immunotherapy patients that we have already built, who has Guardant, and from Guardant, can we build our CHIP data? And TP53 is really tricky because it's one of the most frequently mutated gene in solid tumor in the tissue as well. So you can't, it's hard to say what, where it has come from. So in those cases, you can get help from tissue data, meaning some of the patients will have Tempus, our own in-house NGS or Foundation or Altera NGS. So there's going to be a different source of DNA profiling from the tissue. So you can actually tell what is overlapping and what is not overlapping, okay? So understand that this CHIP is coming from bone marrow only. It's not coming from tissue. So there's going to be a different TP53 variants. So it's not just per gene. There's a TP53 B777I coming from tissue. There could be a T53, H335G coming from bone marrow. So it's per variant level. That's why per variant functionality is so important, and that is the project that Grace and Jessica is working on, that the variant functionality is important. So at the variant level, number one is the tissue and blood overlapping or not. That's going to give you extra level of comfort saying that yes, it's coming from bone marrow. Okay, so that will be important in deciphering our garden data to say, yes, this looks like CHIP. No, this doesn't look like CHIP. And the other thing is, if variant allele frequency is 50%, like it will come as 48%, 82, 52%, does not matter. In a lot of those cases, those are germline mutations. They're not CHIP. Okay. So that's another criteria. So you can look at many of the papers you mentioned and really read it through to see the methodology, like how did they define their CHIP. And honestly, I don't think we should apply that 2% in our paper. If you feel like, because Guardant uses barcode technology, and the reason I use Guardant is the most sensitive ctDNA assay out there. So I can detect up to 0.02%, very low allele frequency. And if let's say there's a TET2 mutation with that frequency, and I think that's real, I don't think that's a noise, and I would take that as CHIP. So just like you've done definition A and B for your mixed response project, you can do the same way. You can do analysis using the 2% cutoff. You can do the analysis without the cutoff and see. We call these type of analysis sensitivity analysis. So you can do a different way. All right, so those are my comments, and those are what you need to focus on for your next presentation. Any questions?
No, actually, I found it, for your information, I found the, slide that, like, people with CHIP is people with CHIP generally shows poorer overall survival. And this cohort contains a lot of, cancers with 5,300 like patients. And the most common cause of death among patients in the cohort was progression of the primary tumor, which the author find it striking. And so, yes, this is our common knowledge, and there were some research that was opposite to our common knowledge, as I told you, like Fire3 trial. So
Yeah, so they're saying tumor specific, but what is so tumor specific about that? And I would say another idea is having healthy bone marrow cell is really important. So we talk about differentiation. So from embryo to our adult human, we think about differentiated cells, and then they they age and they die, but there are cells that are self-renewing, and then they come to rescue. So the bone marrow cells can go to myocardial infarct tissue, and then the bone marrow cells become cardiac myocytes. Okay, so this is like, they have committed themselves to become hematopoietic cells, but then they go back, de-differentiate, and then become cardiac cells. Okay, these are new concepts, de-differentiation. Okay, and that's why bone marrow cells are so important. So what I think is humans have this regeneration or repair mechanism, and the bone marrow cells are heavily involved in there. But if the bone marrow cells have a mutation that will make them less functional of this repair job, then we'll have increased cardiovascular or other toxicity issues. So read more about that bone marrow cells role in cardiovascular health or any inflammation related disease and overall health in that manner, and how CHIP affects that function. So I do think so one is modulating immunotherapy response. The other is people who are getting chemotherapy, like adjuvant chemotherapy, or the chemotherapy upfront with immunotherapy and first-line agent. Those patients do experience side effects. Some get stroke, some get heart attack, some get just, there's a toxicity from the chemo. And a lot of times it shows up as cachexia. They don't tolerate it well. They're quality of life tanks. And Jessica, Grace, and Peter, Will, you've all seen it. Patient like, I can't go on with this chemotherapy because I'm like, my life sucks. You've seen Mary Clark, and she was crying. Like she's like, you can't do this chemo anymore. I talked to Mary Clark yesterday, and I think Peter was there, and Mary Clark is a different person. I don't feel fatigue anymore. I'm like day and night different. So there's that effect of chemo, and that chemo toxicity is much more pronounced when you have CHIP. Okay, so we could look at the chemotoxicity difference. So maybe read more papers on that. Kind of that will guide us to kind of think about our own future projects. But that's another, like it's like a toxicity predictor. So we're doing a lot of proteomics projects to predict toxicity. So I think CHIP is related to chemotoxicity. I don't know whether it has any role in predicting immunotherapy toxicity. No one knows. But immunotherapy toxicity is all what? Mediated by interleukin, right? Interferon, all these inflammation pathways. So if the chip is there, sort of setting the threshold lower to initiate any inflammation process. I don't know if anyone has looked at it, but the role of chip in initiating or prolonging or making more severe immune toxicity, we don't know. So see if anyone had asked similar question, and let us know. Okay,
Okay.
these are all clinically very relevant questions, and this can later pair up with the proteomics and chip, and the radiomics pneumonitis prediction model. So at all these different angles, we can come up with predictors. Okay, any questions or comments?
That's pretty much it.
All right. So we will wrap up today, and I will see you guys soon. Bye.